So insertion sort is another algorithm we can use to sort an array. The idea behind this algorithm is to build your sorted array in place, shifting elements out of the way as you go to make room. This is slightly different from selection sort or bubble sort, for example, where we're adjusting the locations, where we're making swaps. In this case, what we're actually doing is sliding elements over out of the way. How does this algorithm work in pseudocode? Well, let's just arbitrarily say that the first element of the array is sorted. We're building it in place. We're going to go one element at a time and build it. And so the first thing we see is a one-element array, and by definition, a one-element array is sorted. Then we'll repeat this process until, we'll repeat the following process until all of the elements are sorted. Look at the next unsorted element and insert it into the sorted portion by shifting the required number of elements out of the way. Hopefully this visualization will help you see exactly what's going on with insertion sort. So again, here's our entire unsorted array, all of the elements indicated in red. And let's follow the steps of our pseudocode. The first thing we do is we call the first element of the array sorted. So we're just going to say 5, you're now sorted. Then we look at the next unsorted element of the array. And we want to insert that into the sorted portion by shifting elements over. So 2 is the next unsorted element of the array. Clearly it belongs before the 5. So what we're going to do is sort of hold 2 aside for a second, shift 5 over, and then insert 2 before 5 where it should go. And now we can say that 2 is sorted. So as you can see, we've only so far looked at 2 elements of the array. We haven't looked at the rest at all. But we've got those 2 elements sorted by way of this shifting mechanism. So we repeat the process again. Look at the next unsorted element. That's 1. Let's hold that aside for a second, shift everything over, and put 1 where it should go. Again, still, we've only ever looked at 1, 2, and 5. We don't know what else is coming, but we've sorted those 3 elements. Next unsorted element is 3, so we'll set it aside. We'll shift over what we need to, which this time is not everything, as in the previous 2 cases. It's just the 5. And then we'll stick 3 in between the 2 and the 5. 6 is the next unsorted element of the array. And in fact, 6 is greater than 5, so we don't even need to do any swapping. We can just tack 6 right on to the end of the sorted portion. Lastly, 4 is the last unsorted element. So we'll set it aside, shift over the elements we need to shift over, and then put 4 where it belongs. And now look, we've sorted all of the elements. Notice with insertion sort, we didn't have to go back and forth across the array. We only went across the array one time, and we shifted things that we'd already encountered in order to make room for the new elements. So what's the worst case scenario with insertion sort? In the worst case, the array is in reverse order. You have to shift each of the n elements up to n positions every single time we make an insertion. That's a lot of shifting. In the best case, the array is perfectly sorted, and sort of like what happened with 5 and 6 in the example, where we could just tack it on without having to do any shifting, we essentially do that. If you imagine that our array was 1 through 6, we start out by declaring 1 is sorted, 2 comes after 1, so we can just say, okay, well 1 and 2 are sorted, 3 comes after 2, so okay, 1 and 2 and 3 are sorted. We're not making any swaps, we're just moving this arbitrary line between sorted and unsorted as we go, effectively, as we did in the example, turning elements blue as we proceed. So what's the worst case runtime then? Remember, if we have to shift each of the n elements, possibly n positions, hopefully that gives you an idea that the worst case runtime is big O of n squared. And if the array is perfectly sorted, all we have to do is look at every single element once, and then we're done. So in the best case, it's omega of n. I'm Doug Lloyd. This is CS50.